Good morning, Advanced Chemistry. Today we're going to continue our discussion of what happens when certain solutes get dissolved or attempt to be dissolved. And today we're going to focus specifically on putting different solutes in water. And remember, we talked yesterday, there are really three options. One is to do nothing. Nothing happens. Two is to dissolve but not break apart into pieces. And three is to dissociate into pieces and become dissolved. So we're going to talk about how you will be able to decide which one of those three options will happen when you have different types of solutes being dissolved in water. And so to do this, I think the easiest way is to use a flowchart. And so the first question we want to ask is it ionic? So is the solute ionic? Only ionic compounds can dissociate into ions. So those are the only ones that can actually break apart into pieces. And so this really helps get us on track. So yesterday when we were talking about sodium chloride, that was an ionic compound. And so it had the capability of dissociating. Now just because it's ionic doesn't guarantee that it's going to dissociate, but it's a good place to start. So what we're going to do is bring this arrow over here, and we're going to call this yes. Yes, it is ionic. So yes. If it is ionic, the next question we want to ask ourselves has to do with its solubility in water. And this is just something we can use our solubility chart for. And the question is it soluble? So if that compound is soluble, you check the solubility chart, and yes it is, it's an S, then that means that water can come in, surround it. The force of attraction between the water and the solute particle is going to be greater than the solute for itself, and it's going to dissociate into ions. So if this answer is yes, again, then what this is going to do is dissociate so breaks apart into its aqueous ions. Okay, so it will dissolve, and it will dissolve in its aqueous ions, so separated from each other. I noticed there that I spelled dissociates completely wrong. I'm so sorry. I'm missing an O. So there should be an O right there. If it is not soluble, so you look on that chart and it is a non-soluble compound, what that means is that the force of attraction between those two ions is really strong, or between more than two ions, is really strong. So strong that the water can't get in there and disrupt that ionic bond. So if it's not soluble, then what's going to happen is basically nothing. So I'm going to say does not dissociate. I got my O in there this time. And it does not dissolve. So it is not aqueous. So essentially there is no change. It's just it might mix around in there, just so think sand and water, but it's never going to dissolve. So that's what happens if the solute is ionic. Now if the solute is not ionic, if it is in fact a covalent compound, then the next question we ask ourselves, and we were kind of talking about this yesterday a little bit, which is why I checked, the question would be, is it polar? Okay, remember our like dissolves like rule. So if it's polar, it's going to be a lot more likely to dissolve than if it's not. So right off the bat, if it's not polar, we can just draw a line right to this same conclusion. It's not going to dissociate, and it's not going to dissolve, because if it's not polar, it's not going to dissolve in water, which is a polar solvent. if it is polar, this is where, and I think this is the most, I don't want to say confusing, but this is the hardest one to kind of wrap your head around. Polar compounds are covalent. And so what's going to happen is that it is going to dissolve. It is going to become a homogeneous mixture. Okay, so it is going to become aqueous. But it is not going to dissociate. And the reason it's not going to dissociate is because there are no ions that make this compound up. So it's not going to break into pieces. It's not going to dissociate into ions because these molecular compounds aren't made of ions to break apart. So using this, we're going to apply this to some examples. And because I'm worried about our videos being too long, it's going to be in the next video. So thanks for watching, and make sure to watch the next video as well.